Alright, so when we were dealing with triangles, we looked at the trig functions sine, cos, tan, right? And we met how you know how to find this stuff using a right angle triangle. But now we actually need to know how they are graphed, what the shape they look like. Okay, so let's just draw each individual one. So let's just start off with y is sine x. So if I draw a graph like this, sine x looks kind of like a wave. So what I mean by that is it moves something like this. Like so. Okay, so this is what a sine graph will look like. And there's a couple of key points that you need to be aware of. First things first, the y-axis, x-axis. The maximum the sine graph can ever be is 1. Okay, so that's the maximum it will ever be. And the minimum it will ever be is -1. Right, where it crosses the x-axis, well obviously this is 0. The first time it crosses it is when it's 180 degrees. This is all in degrees, by the way. And this would be 360 degrees. So in fact, it's just multiples of 180 upwards and downwards. This would be -180, this would be -360, and this one would be 540. So you have to add 180. You keep adding 180. Now this graph is known as a periodic graph. So periodic just means it repeats itself. Like remember in the when we're looking at series, it's going to repeat itself. So this repeats itself every 360 degrees. So you just have to repeat every 360 degrees. And so that's basically the sine graph. You have to be so in this graph you have to be aware of just the shape and where it crosses the x-axis, where it's also maximum minimum. So it's maximum when it's 90 degrees in the middle, minimum when it's 270 degrees, and so on. And also what is periodic as well. Okay? And so we can also look at a domain and range. Domain is the possible x values. So in this case, x can be any value, right? It has a point for any value. And the range, which is the possible y values, is between 1 and -1, meaning it can't be above 1 or less than 1. So this is the graph for sine x. Right, let's draw cos x as well. So cos x is very, very similar to sine x. In fact, it's actually got the same shape, but it's just translated to the right a bit. So in this case, cos x will look something like this. Sorry about the graph. Like this. So as you can see, the shape is very, very similar to the sine x graph, right? But it's just a couple of points where it crosses which are different. So first things first, it crosses the y-axis at 1 maximum and -1 as the minimum values, same as the sine. Now this point here where it crosses the x-axis, for the sine graph it was at 180 and multiples of 180, right? This one here is going to be 90 degrees and -90 degrees. So this one will be 270 degrees. So it's essentially like the sine graph just moved left by 90 degrees. Okay? And so therefore the minimum would be at 180, this would be -180, and so on. Domain and range, obviously the domain also, it has a value for all x's, so x is all real values, and range, once again, it's the same as the sine graph, it's between -1 and 1. Okay, so just be very careful or be aware of the general shape. The last one is the tan graph, so y is tan x. Now this is completely different to the previous two graphs we looked at. And in fact the tan graph actually has some asymptotes. Okay, so the asymptotes occur firstly when x is equal to 90, and then the next one is going to be at 270, and this one here is going to be -90 and -270 as well. So it's every 180 along as well. So once you've drawn the asymptotes, now we have to draw the general shape, and the tan graph looks something like this. This is the general shape of a tan graph, which is going to be repeated between every asymptote. So here as well, you're going to have a general shape like this, and here, like so. So this is the tan graph. Like a couple of key points to note is obviously the asymptotes the asymptotes which occur every 180, and also where they cross. So in this case, this is going to be at 180. This is going to be at -180 as well. Right, domain and range. Well, range is the possible y values, and so in this case, there's no like maximum, minimum. Y can just be any real value. The domain, obviously, it can also be any real value, but it's just that x is not equal to when it's in asymptotes, right? So it's when it's 90, when it's 270, when it's -90, and so on and so on and so on. So this will go on forever, basically. So just be very aware of the shapes. I think guys should try and memorize the maximum minimums, where it crosses the x-axis, when it does have maximum minimums for sine and cos, and for the tangent graph, memorize the asymptotes and also where it crosses the x-axis. This is very important because in the exam, they'll give you like graph transformations or be asked you to draw certain trig graphs. So you need to be very, very familiar and comfortable with dealing with these trig graphs. Right, let's try some transformations. So let's say I want to sketch the graph y is sine theta minus 90. So we looked previously in the previous chapters how to transform graphs. Remember, there's like translations, there's stretching, and there's reflection. So it's the same thing. We dealt with it when we were doing x squared graphs, but we're now going to be dealing with it when we're doing trig graphs. But it's the same effects that which happen. Okay, so let's start off with this sine theta minus 90. This one we can if f of x was sine 90, right? Sine theta, sorry. Then this sine theta minus 90 would be equivalent to theta minus 90 in here, right? And we know if it's inside the bracket, it's going to affect the x-axis, and it's going to do the opposite of what we expected. So if it's minus 90, it's actually going to move right by 90. So if I was to draw, let's just draw it from 0 to 360 every single graph. So if I were to draw the sine graph originally, it looks something like here, right? But now if I move everything to the right by 90, these will all be moved right by 90 like this, and like so. And so this red graph would represent sine theta minus 90. Okay. Let's try another one. Let's try maybe y is equal to 1 over 3 cos theta. Right, same thing. The 1 over 3 is outside. So if I said f of theta was cos theta, then this here would be y is equal to 1 over 3 f of theta. And we know if 1 over 3 is outside, it's going to affect the y values and it's going to affect it as they would expect to, right? So therefore, if I were to draw the cos graph, it's going to look something like this. But remember, the maximum minimum would used to be 1 and minus 1, right? But if I multiply by 1 over 3, it's now going to be 1 over 3 and minus 1 over 3, like this. And it's still going to cross at the same positions, 90 and 270 degrees. So as you can see, all the transformations, they're still applied as the same they would. It's just to these trig graphs now. Let's try another one. Let's try maybe y is tan theta plus 45. Okay, so the 45 is inside the bracket, meaning it's going to affect the x or the theta values in this case. And it's going to do the opposite, it's going to move it left by 45 degrees. The original asymptotes for tan was at when it's 90, right? So if it moves left by 45, it's going to be now when theta is 45 degrees. And the other one was originally when it was at 270. So if you move left by 45, it's going to be at 225 degrees, right? And so now I can just sketch in between the general shape. So it's going to look something like this. It's going to look something like this, and a bit like here. Okay. Let's try another one. So let's try maybe y is sine 2 theta. This is equivalent to saying it's f of 2 theta, right? Y is f of 2 theta. Once again, it's inside the bracket, meaning it's going to affect my theta values, and it's going to divide it by 2 rather than multiplying it by 2. So it's now going to look like a sine graph, but now there's going to be 2 sine graphs. Because originally this here, it crosses at 180, right? But if you divide it by 2, it's now 90. This will be 180, 270, and 360. And 1 and minus 1. So as you can see, you have to be very, very familiar with where the normal graphs cross the axes and what the general shape are, just in order to apply these transformations with a bit more ease. Let's try a cos one. So let's try y is 1 plus cos theta. This is equivalent to f of theta plus 1, right? So that means the whole graph is going to move up by 1. So the cos graph is now going to move up by 1. So it's going to look like this now, right? Because everything is moved up by 1, so this is 0. This is now 2, because it used to be 1, move up by 1 is 2. But it's still, this point here is going to be 180, and so on and so on. Let's try one reflection. So let's try maybe y is equal to minus tan theta. So if it's minus tan theta, it's going to affect the y values, right? So that means they're going to be reflected up and down in the x-axis. So therefore, the asymptote is not going to change. So this is when theta is 90, and also when theta is 270. The general shape look like something like this, right? But if it's going to be reflected, then it's going to be the opposite way around. So it's going to look something like this, and like so. Okay. So as long as you're very comfortable with these graphs and you're comfortable with transforming graphs, then there shouldn't be too much of a problem when trying to deal with these transformations.